Today's lesson we're doing section 10.2, which is about logs and log functions. Today we're going to discover what logarithms are and how they relate to exponential functions. Logarithms are exponents. Anytime you have an exponential or a power expression or power function, it can be written in logarithmic form. You have three things on this page. We have something written in exponential form, which is what we're used to seeing. 2 to the third power equals 8. Any number to a third power or to a exponent equals some value. Remember, the larger number here is called the base. Okay? This is our exponent, and the 8 just happens to be our result. Okay, then we have logarithmic form. Okay? These are equivalent. Okay? The exponential form and the logarithmic form that you see here are equivalent. You see a lot of the same numbers. You see the 2, the 8, and the 3. They're just in a different order with this log. Okay, this 2 is still considered the base. And then we have a logarithmic function, which is just writing it in function notation, whether it's y equals or f of x equals. Okay, that wouldn't matter. Okay, a couple conditions on logarithmic function form is that your base of your log has to be greater than 0, cannot equal 0, and the x value, the number that is next to the log with the base, has to be greater than 0 as well. Okay, the moral of the story is logs can be written as exponents and exponents can be rewritten as logs. Anytime you have an exponential function or an exponential expression, it can be rewritten as a log expression. Okay, notice the double arrow here, stating that this can go in either direction. When you have an exponential with an x raised to a y power, which equals to a z, it can be rewritten as a log to that base of x, to that z, and it equals y. Okay, when you're rewriting in logs, the bases, okay, are found there. Okay, the exponent is what the log will equal. Okay, we need to know this. Okay, you have to know how to be able, it's very important throughout this chapter, to be able to know how to rewrite any exponential expression into a log expression. It is imperative. Must be able to do it. So we're going to practice it a little bit. Okay, we're going to rewrite these in logarithmic form. I'm going to show you the first one. Again, identifying the parts. We have base of 5, exponent of 2, and it equals 25. So we're going to write it in log form. Okay, we have log with now a base of 5 of 25, and it equals 2. Okay, basically what this is saying is, okay, we have a base of 5, and this notice is that 5 squared, okay, is 25. Those 5s are the same, and it's equal to 2. Okay. Take a moment, pause the video, and rewrite 3 to the negative second power equals 1/9 in logarithmic form. Okay, we're back. This is what you should have come up with. Log base 3 of 1/9 equals negative 2. We have to be able to go the other direction as well. We have to be able to take logs and rewrite them into exponential form. Okay, so we have log base 6 of 216 equals 3. That would rewrite as 6 to the third power equals 216. That should make sense. Again, they should be true expressions. Okay, pause again the video for a moment. Okay, rewrite log base 27 of 9 equals 2/3 in exponential form. Okay, we're back. Should be a base of 27 raised to the 2/3 power equals to 9. Whenever you're rewriting from log to exponential form, the exponential form that you get out should be a true statement. If it's not a true statement, then we wrote it incorrectly. This is going to allow us to evaluate. Basically, when evaluating, what we're going to be able to do here is take log base 2 of 32 and find what it's equal to. To do this, okay, right now I'm going to say that it's equal to x. Okay. Then rewrite it in exponential form. Base 2 to the x power equals 32. Now I'm going to basically just figure out what number to the, or 2 to what number, to what power equals 32. Basically rewrite 32 as a base of 2. It's 2 to the 5th, so that means x has to equal 5. Let's see this one as well. Okay, we got log base 4 of 164. We want to evaluate this. It means we want to know what it's equal to. Okay, we don't know what it's equal to. So again, set it equal to x. Use your exponential notation. base 4 to the x power equals 64. Remember, 1 over 64, okay, probably means an inverse. Okay? 1 over 64 is 1 over 4 to the third power, which is 4 to the negative third power. So that means x has to equal -3. A couple of rules to remember with logarithms. Okay, one is dealing with a log with a base b, and the number that is next to it also has a base with a different exponent. But what's important is that these bases match up. When those bases match up, it is similar to them canceling out. Okay, and that exponent that's left is the value of that log. So our first example is using this method. You got log base 5 of 5 to the 8th. You notice that the 5s match up. Okay, basically they cancel out. Okay, your evaluation of this is 8. The second rule is when you take this exponential, you have a base of b, but in the exponent now there's a log with the same base. Okay, when that happens again, it's like they cancel out, okay, and leave you with that value of x. So our second example, 3 to the log base 3 of x minus 4 power. Okay, notice that 3 and the log base 3 match up. It's like they cancel out. Okay, what's our evaluation of this? Evaluation of this is just x minus 4. This will allow us to also solve. What we're going to be getting to is solving equations, okay, where 5 to the x power equals 2 to the x minus 1 power, and we want to be able to solve that. Okay, and what we see is that they don't have the same base. Okay, if they don't have the same base, we're not going to be able just to set the exponents equal to one another. If we can't manipulate them so that they have the same base, there's got to be another way to do this, and logarithms are the way. So we're building up to that. We're building up to that. We're not going to be doing these types of equations yet, and we're getting there. Okay, so we're going to solve log base 4 of x equals -2. How are we going to solve that? Use our exponential form. Okay, what does it mean? Base 4 to the -2 power equals that x. Well, very simply then, okay, our answer is 1 over 4 squared, which is 1 over 16. And this is a very important thing to remember. Remember, the base has to be positive, and the number that is next to the log of the base has to be positive. Okay, so if we get a value of x that is not positive, okay, it is an invalid answer. Okay. We're also going to solve this one. Okay. Notice it's log base 7 of 2x plus 1 equals log base 7 of 3x minus 5. Remember again what an equality means. An equality means that both sides are the same. Okay. What we should notice is that it's already log base 7 on both sides. It's not that you can divide log base 7 away or they cancel away. It's just that they're already the same. If they are already the same, then what we need is the 2x plus 1 and the 3x minus 5 to be the same. So we can ignore the log base 7s, set these values equal to one another, solve, get an answer of 6. But again, make sure that these values are positive. So we should make sure quickly input that 6 and make sure that those 2x plus 1 and the 3x minus 5 are positive values. As long as they are, everything is okay. We're going to do this first example together. Log to the 1/2 x power equals -3. What we would do is to solve for x. Again, we got to make sure that x is positive in the end. But 1/2 is our base. We're going to raise it to the -3rd power, and that's going to equal x. This is just simply rewriting the log into exponential form. Again, it is imperative that we are able to write logs into exponential form. Okay, what this means for us is it really means 2 to the 3rd power. Okay, what is 2 to the 3rd power? It's 8. That is a positive value. That is our answer. Okay, in lieu, something new on our videos, in lieu of a video quiz, okay, what I'm asking you to do is there's going to be 3 examples that you're going to have done for me tomorrow in class. Okay, this is our first example. Okay, you will do that on your own tonight. You will bring it in tomorrow and answer for x, and we will go through that answer. This is our second one. Okay, so there's 2 of the 3. Okay, if you need to pause the video to write those down to be able to do them later, please do. Okay, but these need to come into class tomorrow morning done. Okay, your homework, your points for your video will be based upon these 3 problems. These are 2 of the 3. Okay, moving on. We're also going to tackle inequalities. Okay, and there's 2 rules about inequalities. There's all depending on how does the inequality open. Okay, we have log base b of x greater than the y, and we have log base b of x less than the y. When the log is greater, this is how we set up the inequality. When the log is less than, this is how we set up the inequality. Why with the 0? Because again, this x has to be positive. Okay, when it's greater than, the x will be positive. We don't need to worry about it. Okay, so when we see log base 5 of x less than 2, okay, we have to notice that we're going to follow that pattern. So very simply, we set the 0 to one side, 0 less than x, which is less than 5 to the second power, the base to the exponent. Okay, and very simply, we can solve that, and we have our answer. Okay, x is somewhere between 0 and 25. Okay, in the other aspect, we have log base 6 of x greater than 3. Now we don't have to worry about the 0. Okay, we can just set x greater to the base to the exponent of 3, and x has to be greater than 216. Remember these inequality rules, please. Okay, we'll go through this one together. What we have is log base 10s on both sides. Log base 10 of x minus 4, or 3x minus 4 less than log base 10 of x plus 6. Okay, we want to find the values of x that make this true. Couple rules is though, again, remember, okay, something very commonly forgotten is that these values, according to our logarithm rules, have to be positive. So we have to take those into account. 3x minus 4 has to be greater than or equal to 0, and x plus 6 has to be greater than or equal to 0. When solving the inequality, we could possibly get an inequality that leads us to values that don't make those true. So we have to ensure that those are true. So a couple things that have to happen. X has to be greater than 4/3, and x has to be greater than or equal to -6. Those have to be taken into account in our final solution. Now, because we have log base 10s on both sides, it doesn't follow the rules on the last page. We have log base 10s on both sides. We basically ignore the log base 10s and just make sure that 3x minus 4 is less than x plus 6. We solve, we get x is less than 5. Now we have to put everything together. Okay, a number line will be very helpful on this. Okay, this is our final solution. How did I know that solution? Okay, I'm going to get a number line out. Okay, I'm going to put the numbers in order as they need to go, and I'm going to see in what way we go. Okay, we know we have x has to be greater than or equal to -6, and x has to be greater than or equal to 4/3. Those two values, again, make sure that those values next to our logs are positive. And x has to be less than 5. So I go that direction. Where are all three regions overlapping? In here. Okay, so that is our solution. X 4/3 less than or equal to x. Okay, less than 5. This is your third example that you're going to have done for class tomorrow. Okay, so again, you have 3 examples to be done in class tomorrow. Okay, again, if you need to pause this and write this down, please do. Okay, but I expect that those 3 are done. So in lieu of a quiz, you do not have a quiz to do. Okay, you are working on these 3 problems. These need to be done for class tomorrow.